Hello, everybody. Welcome to our session, and thank you very much for joining our session for your listening. And today we will explain our efficiency improvement in our boiler systems and how it is related with the sustainability and the contractual excellence management. So I will start with our company introduction first. Eren Enerji is the biggest power generation company in Turkey. Almost 6% of the Turkey total electricity needs we are generating. And Eren is the most important power generation company in Turkey in terms of the security of supply of electricity. Especially, we are in collaboration with the governmental offices and the Ministry of Energy to follow their demand planning and the total Turkish needs. And our power plants are located in the west side of the Black Sea region, which is very close to Istanbul area, Marmara area, meaning that the almost 30 million people are served by Eren Enerji's power plants for their electricity demand. So it means that there is a very critical position of these power plants. And this situation makes me to focus on contract and commercial management heavily during the cooperation with our contractors and also stakeholders to provide a sustainable, safe, and continuous electricity generation. In addition to the power plants, Eren is also operating the second biggest port in Turkey in terms of the dry bulk cargo. Eren Port is heavily used for the coal handling with the imported coal supplied from many foreign countries to feed the power plant for the coal generation electricity. And in the amount of 7 million tons per year, we are consuming coal just for our power generation needs. In addition to this, third-party clients have also contracted with us to use the port, and they bring almost 3 million tons per year, which means the total amount of handling capacity reaches 10 million tons annually. And actually, our capacity is higher than the 10 million, which is around 15 million. But we are consuming the 7 million plus the third party is bringing 3 million more. And then we are reaching the 10 million tons per year. And me personally, I have been contributing to Eren Enerji about 17 years in total, which includes the contracts and the planning manager role. For 15 years with the responsibility of contract and commercial management for more than 2,000 contracts and with more than 1,000 contractors from 30 different countries. The total contractual value in my obligation, in my responsibility, exceeded $5 billion, including EPC contracts with the Chinese contractors in the amount of $1.5 billion. And for example, you can see in the presentation slide that we have 3 power plants mainly. And the ZS1 is constructed with the many European countries, whereas the ZS2 and ZS3, which are the other big power plants in our territory, they were constructed by the Chinese contractors. So because of these power plants in construction process, we are in touch with the many different types of the contractors and different contractors from all over the world. So maybe more than 1,000 contractors, we have the contract with them. So it's a very tough situation to manage all of these contractors at the same time. As an EPC contractor, we are working the main Chinese contractors, but of the balance of the power plants, we are still in connection with the other companies. And for the last 2 years period, I have been performing a CEO role by leading the company with 1,400 employees, especially focusing on power generation, human resources, sustainability process, digitalization investments, and also the new investment areas for the power generation industry. And in these circumstances, actually, we have a very big challenges related about the operation of the power plant. One of them is carrying out the efficient and safe combustion in the boiler with the lowest emission levels as much as possible. During the operation of the power plants, we are working with many different types of the coal composed of different chemical parameters, which is causing variation in the combustion. This is a very big difficulty for our operators and engineers to arrange all the actions during the daily operations and put some logical rules in our automation system. Stable combustion has a very big crucial role to implement these actions, the daily actions, successfully during the proper power generation process. While having stable combustion in terms of the heat and the pressure balance, actually my colleagues will explain more detailed information related about this stable combustion. In this area, we should follow the emission limits also at the same time to avoid exceeding them to provide clean energy to the environment. On the one hand, we need to fulfill our country's power generation needs, but at the same time, we have a responsibility and the respect to the environment also. So we need to follow our legal emission limits also. In this case, the combustion inside of the boiler, if it is efficient and the proper, if we are burning the coal with the higher efficiency level in a proper way, then the carbon emissions will be low and emission levels will be easily controlled by us. In order to ensure stable combustion, to have more efficient burning and low emission levels, we started to investigate new technologies from all over the world. In every year, we are trying to increase our efficiency levels by investigating all the market conditions, market opportunities, and then trying to reach the best practice in our power plant operation. Then it will give us higher efficiency levels with the lower coal consumption, of course. And together with my colleagues, with my team, after an intense review of the technologies available in the market, then we found that replacement of the burner equipment in the boiler with an updated, different design is an option for us to reach our targets. It means that the replacement of the burner inside of the boiler is a very critical issue, and it's not an easy and risk-free process. And unfortunately, also, this is not a proven technology, and this is not experienced implementation in this scale with the similar size of the power plants. So we couldn't find a suitable, exactly 100% same reference plant in the market, which they already changed their burner type and the design. Besides, we have not worked with this supplier, who is the British supplier company, actually. We contracted with the British supplier, and we didn't know them before. And also the other supplier companies in the tender stage, we didn't have so much experience with them. So it means that we didn't know any of the contractors during the tender process. And each of them offered the different technologies and the technical solutions. But of course, it is creating a technical confusion and debate within our technical team. And it is an interesting point that, and I gave the name of this presentation and application for the award to the WorldCC. And I said that changing the heart of the body, changing the heart of a body. Why I gave this name to the project? Because one of the company in the tender, they told us the replacement of the burner inside of the boiler, it is same thing that whether you are changing the heart of a human body. This is very critical process. So it looks like changing the heart of a human body. So we called the project like that, and then actually this company who is saying this wording statement, changing the heart of body, they are saying that it's a huge risk for us to under this decision. And as a company leader, as a CEO, I was faced with the critical challenges to take this decision, such as technical risk of the replacement of the burners, tough contract management with the new suppliers, and huge cost of the implementation. The cost of the implementation amounting to over 3.5 million pounds. On the contrary, I was so excited with our together colleagues. I was so excited to have an opportunity to be successful with an unexperienced issue and with a great outcome in terms of huge cost savings. Because if we are successful at the end of this project, then there will be a huge gain in terms of the cost efficiency and also the technical efficiency. It will lead us to reduce coal consumption and high environmental benefits by reducing the emission levels at the same time. And because of this risk, so how we will manage this risky situation, I will explain more this kind of the risk management technical approach and the commercial and the contractual management approach of our case. In order to eliminate these risky steps during this evaluation period, I pushed my colleagues to be sure as much as possible about the technical results, because nobody was 100% sure about the technical results at the first stage. Rather than the commercial and the contractual obligations, then I strongly recommended to focus on the technical side of this project. So my colleagues, they tried to increase the probability of technical outcomes by executing several steps. And one of them is inviting the technical suppliers of the tender company to our power plant sites. So we invite them to our power plant site and allow them to investigate all the equipment and the systems and make a technical deep analysis by allowing them to reach all data and information. So it means that we shared all the information and the data to the counterparty, and my team and the tender company's team gathered all together in the same room, in the same power plant area, and they studied together. And under the collaboration of both of the teams, then they calculate all the technical steps together, and after the study of the calculations, they will be more satisfied about the results. So our people shared this information with the open communication for the front engineering process, and they monitored all the calculations. These calculations were done by the tender company engineers also. And after the heavy study on this front engineering stage, my colleagues became more satisfied with the methodology, implementation methodology, and the technical offer due to the accuracy of the higher accuracy level of the calculations and the technical approaches. So in the first stage, open communication, gathering all together, study on the technical documents, technical informations, and all the methodology, implementation methodology, and then increasing the accuracy level of the calculations, the outcome will be more satisfactory to our side. However, this was not a sufficient step for me to be convinced to enter this risky and costly implementation. Why? Because it is not a proven technology yet. So that's why I asked my colleagues to visit a reference power plant to see the previous examples of similar technical solution. However, of course, we don't have any 100% reference technical solution. So supplier company suggested to visit a power plant in Bulgaria. Due to the absence of the exactly same example, they suggested the Bulgarian power plant with the lower capacity. But at least they already implemented a retrofit project and they reached a significant improvement during the burning process. So I accepted to visit that power plant in Bulgaria, and we established the technical team for this visit. And they went to Bulgarian power plant and they studied on the already implemented project. And after the visit was completed, my technical team reported in a positive way about the improvements and the actions which are taken according to their internal evaluation. And this reference power plant makes us, together with the our power plant site technical deep analysis study, and both of them, these two actions, one of them is our site power plant technical study, the other one is the Bulgarian power plant visit. So both of them at the same time make me more confident about the capability of the company, tender company, about their commitment in their technical solution. In addition to these technical evaluation, of course, we are handling so many contracts, so many commercial agreements. We know how to use these kind of contractual tools. So in a tradition, I asked to supplier company to make a guarantee for the technical outcomes in the contract. And I had an opinion to apply liquidated damages as a penalty and liquidated damages related remedy clauses in case there is a failure or unsatisfactory results at the end. However, of course, all of us know that even 10%, 15% liquidated damages amount or remedy actions will not help us to cover our loss, because even a one-day shutdown without generating electricity costs huge amount of money, exceeding the total cost of the contract. The total cost of the contract was around 3.5 billion pounds. But even for one day shutdown and the lack of power generation costs higher than this amount. So any kind of the liquidated damages clause or repair work will not compensate the cost of the failure. So because of this issue, I focused on trust relationship. Mainly the trust relationship is the key point here, and the intense communication, openly communication with the supplier. This is the more critical part of our management, rather than focusing on the liquidated damages or contractual mechanisms. And increasing the technical evaluation by site study and the Bulgarian plant visit helped to be more comfortable about the execution of the process and the results. In any case, supplier accepted to provide performance guarantee letter in amount of 10% of the contract price and guaranteed performance parameters for boiler efficiency, 0.5% improvement, carbon monoxide emissions with 10% improvement, and NOx emissions with 20% improvement. They already agreed on the contract. They signed contractual guarantees, which are subjected to liquidated damages in the amount of 10% of contract price. However, any kind of failure of this implementation on boiler will cause a serious damage on our power generation and threaten the supply security of not just for our power plant. Actually, it was a threatening point for the supply security in Turkey in terms of the electricity supply. Therefore, liquidated damages and the guarantee letter mechanism was playing as a tool for me, just a tool for me to push supplier as a pressure on their duty to follow their commitment. It was not a compensation. It was just a tool to push them. At the latest stage of the decision-making process, I made a final presentation to our board board of the company with the participation of our chairman, and I explained the benefits and the risks of the project, and tried to point out the investigation of our site and power plant visit in Bulgaria. And I explained the trusts on the technical calculations monitored by our team also. So the proposed benefits were so attractive. However, the risks stand heavily before my explanation. So then, after I explained all the story, like I explained to you, I explained all the story to our board, and then they were convinced after hearing all these steps. And at the last stage, my colleagues also will go into detail about that, but just a very short summary of the issue, of the results. After the implementation was carried out and finalized during our plant maintenance window, we were looking for the first results of the implementation, whether this project is successful or not. And it was a very nice situation for us that we had a great success at the end, which was more than our expectations, actually. Boiler efficiency was improved as 1.75% from the existing point, which is more than 3 times better than the guaranteed level. And this great performance enables us to reduce almost 30,000 tons of coal in our consumption per year. And maybe it seems a small portion compared to the total yearly consumption. Total yearly consumption is almost 7 million tons. But just doing this project, we can have ability to reduce 30,000 tons of coal consumption. And this is just for one unit. We have 5 units. This is just for the 1 unit. So if we can implement it in our other power plants, then this consumption can be getting better also. And other cost benefits also come from the energy consumption of the equipments, the funds used in the process. So ammonia consumption also we have to fulfill the emission control steps. So at the end, instead of using 6 meals, for example, then we have an ability to use only 5 meals. So 1 meal is not used for our general daily operations. So it means that we have also efficiency in the electricity energy consumption during the operation of the process by using the other equipments. So at the end, as a result, the total cost benefits reaches $3.7 million American dollars per year, which is the result of an investment of this project. The investment amount was around 3.5 million pounds as the capex value, and the benefit is higher than the capex. So in just 1 year, just for the 1 unit implementation, the benefit is higher than the capex value. And in addition to the financial gains, environmental benefits are so significant, which makes us so happy about the results. So carbon monoxide emissions and the NOx emissions are reduced as 68% and 43% respectively. So in summary, in the final wordings, in summary, and then I will forward the speech to my colleagues, our colleagues and me involved in a very difficult and risky decision-taking process, but focusing on the trust relationship and creating more technical and commercial approaches rather than transferring the sole responsibility to the counterparty, provided better understanding the roles and the execution steps for everybody in the process. So we understand the roles and the counterparty very well, better than giving the responsibility to the counterparty by using just some articles. So this methodology created a healthy communication environment by avoiding to hide the information or data necessary to be shared with the parties to reach a mutual success. So we are so happy about the final stage, the final outcome, the result of this project, and then we have a target to implement the same process to our other projects also. So now I will forward my speech to Mr. Yılmaz Özdemir, who is the technical director of our all power plants, and then he will explain some details about the technical side. Thank you.
Thank you, Mr. Ömer. Now I will share our presentation. This is Yılmaz Özdemir. I am Technical Director of Eren Enerji, and I will try to explain about RGM project, how beneficial and how can I say, efficient project is this. And for this presentation, for the first period, Mr. Mehmet Emin Balyamez will continue the presentation. And he is our operation manager for ZS2 power plant. Mr. Mehmet Emin, could you please continue?
Okay. Hello, everybody. I am operation manager of ZS2 power plant. And now you can see our old type burner. We have a low NOx burner, but we had many problems. You can see the burner, the mesh. In our civil link causes burner the mesh like this, and under severe causes long flames. And so we decided, as all Eren team, retrofit our burners with RGM company. RGM company is combustion optimization company, UK-based company, and we have excess air problem, we have CO problem, we have NOx problem, and we changed the burners. We have 24 burners in our boiler, and 4 of them are plasma ignition burners, and we use these burners when our unit startup operation. Please change the screen, Mr. Yılmaz. Yes, we have problems I talked about, and with RGM burner modification, now we change burner primary air nozzle and new secondary swirler. Swirling is so important thing of combustion, and flame stability is achieved using the secondary air swirler, which creates large internal recirculation zone. The coal particles enter this internal recirculation zone and are stopped from traveling further into the furnace. The internal recirculation zone is zero oxygen flue gas zone, where the coal releases its volatiles. And then we have short and stable flame formation in our boiler with RGM burner. And in installation periods last year, we had so many meetings, morning meetings, and with RGM supervisor, with RGM team, and our mechanical team, and we operation team. We have many experience about combustion and our boiler combustion. And after these meetings and short meetings in every day, we decide something, we change something, and which suits our boiler, our other mechanical things. Then continue, please, Mr. Yılmaz. And you can see our burner flame at left side and RGM burner. You can see flame holder and internal recirculation zone. And at right side, our old burner. And you can see excessive heat across the furnace and the long flame. And distribution was not good. Now at RGM burner, our temperature distribution and flame distribution very good now. And RGM change in our burner, you can see coal concentrator structure and tertiary air sliding damper. They installed a new design, primary air pipe. They changed the pipe and ribs coal, which provide our coal homogenization. And homogeneity is very important. Coal homogeneity is very important in our burners and something like that. And then this is the critical picture you can see. And our now at left side baseline test, RGM baseline test, we see, and RGM team and we all together see our flame so long and temperature distribution in boiler and like this. And after retrofits our burner with RGM burner, and now our flame now at combustion zone as it should be. And now temperature distribution is so good now. Also carbon monoxide is better. So outputs, what is our outputs? Boil efficiency increase, fan energy consumption decreased, emission reduction, reduction of chemical is ammonia in our SCR. And we can run 5 mil. We have now totally 6 mils, but now we can run at 5 mils and no CO exceeds, and increase our availability to this important thing,
Thank you, Mr. Mehmet Emin. Now I will continue. As also Mr. Ömer mentioned about very important outputs of this project. The most important output of this project is the increasing boiler efficiency around 1.75%. And this efficiency increases benefits per year is around $2.9 million. How we achieve this target? These burners provide us better combustion in the boiler site, and for this also we decreased total air feeding to the boiler, and also it provides us to equal heat distribution in the boiler. That's why the steam temperature became more stable, and that provides us better efficiency in overall unit. And as I mentioned about total airflow, these burners can work with less air amount comparing with the old burners, and that's why we feed boiler less primary air, less secondary air, And with this, we need to give less heat to the boiler to provide enough heat to the boiler. Yes, when we feed less air to the combustion room, it also decreases the power consumption of the primary and second FT fans of the boiler. And also, as we mentioned about these burners are the low NOx burners, and the combustion distribution of the boiler is more efficient, and it causes to produce less NOx and less CO emissions in the boiler. And this causes when the boiler produces less NOx emissions after the burning. This also provides us to use less ammonia in the SCR system, and the efficiency of the burning process, we can burn coal in a better way, and it also reduces the loss of ignition or unburned carbon in the fly ash and after burning process. Because of the low NOx emissions after burning process, we consume less ammonia in the SCR system, and this also saves ammonia consumption, and its benefits for us $234,000 per year. Also, when the boiler efficiency increased, we can reach full load with 5 coal mills, and this means we can shut down 1 mill. We can keep it as a standby mill, and also when we keep this like that, we consume less primary air, and we can consume less electricity for total coal mills. As you can see, when we run unit with 6 mills, totally we consume about around 2,417 kilowatt per hour. But when we run with 5 mills, we consume around 2,170 kilowatt per hour. And when we run with 5 mills, as I said, we consume less primary air, and it also primary air fan electricity consumption decreases, and the total coal mill electricity consumption also decreases, and we can save around $151,000 from this operation. And with running units with these burners also, it is easy to maintain, easy to operate these burners comparing with the old burners. Also, with these burners, O2 control is also better than comparing the old burners. And when the combustion is better, also the heat transfer inside the boiler is better than comparing with the old burners. And when we are running with the 5 mills, 1 mill is a standby. When one of the mill has problem or other issues, we can immediately start the standby mill and continue full load operation. And this is the total benefit of our project investment. As Mr. Ömer mentioned about the total benefit of this project, $3.7 million per year, increasing boiler efficiency and using less chemicals and saving some electricity from FT fan, ID fan, booster fan, and this kind of improvements provide these benefits for this project. It was really exciting project for us, as Mr. Ömer mentioned about. This is tailor-based project, not standard project. These burners developed by RGM for our boilers, and these are the, how can I say, as I said, these are the tailor-based. I think this is for all I want to say. And Mr. Ömer, Mr. Mehmet Emin, do you have anything to add?
This is, yes, this is summary of our all savings money, and it is important thing is our emission saving. Now our carbon monoxide and our NOx emissions decreased about NOx emissions, we can say decreased about 30%, and our CO level decreased about again 30%, and it is good savings from this project. Good important things we achieved, and emission decreasing, our emission decreased, and NOx and CO emissions now maybe I can say 30%, about 40% decrease. Now we have very good flame shape and flame holder in our boiler, and now our flame short and as it should be at now combustion zone. We have no boiler pipe damage. We have no final superheater damage, for example, in boiler, and everything is good. And thank you everybody, and thank you Mr. Ömer, and he started and he decided this project, and thank you our all managers and all team, and thank you listening to me.
Thank you very much, Mehmet. And for the final words, actually, I can say that as you listen to our colleagues, it's a very technical, sophisticated project. And of course, there are many topics to be discussed in the technical side. However, in order to give the exact the summary of this contract commercial management of this project, that because of this high risky, in terms of the technical matter, high risky level of this project, then instead of giving the responsibility of the contractual rights to the counterparty, then the collaboration is much more critical. We can say easily like that. So the mutual collaboration of the parties in this kind of a technical risky projects is better to reach to achieve the successful results by sharing the communication in an open way and not hiding any kind of information and giving all the necessary data and the documents to the counterparty. And then you need to be a team, understand your roles, and understand the objectives of the project is very critical and the underlying success factor, what we believe. So you can think about your own projects, and definitely you will find so many different ways to reach this proposed and requested targets with your own decision-making process. Creation of the channels will be done by your side according to your project needs and requirements. So this is what we did according to our natural business way, according to our industry. We found this kind of things, channels to solve this risky management process, and then finally we had the successful results. And any kind of questions, you can send the questions to us, and then we will be happy to reply about that, and then we can discuss all the other details. Thank you very much for your listening.